Hey guys, today we're going to look at integrating trig functions. I know they're your favorite things, but we're going to start out pretty easy and then I'll give you a chance to copy down the 6 basic integration rules. These should be on a handout that you had in the past, but I'm not sure if you still have it. So I'll put that up here, and I would suggest maybe you pause the video and write those down so you have them, okay? But we're going to do a few examples and then tomorrow you can practice. I think Friday I have it being a catch-up day, but that'll wrap up the week for us. So let's go ahead and start looking at it. So our first one I want us to look at is the integral of tangent of x dx. Okay, so there is a formula for this, and if you were to look at your sheet, if you have it, you could go ahead and find it, but let's see if we can go ahead and derive it, okay? Because it's a pretty basic one to look at. Since we've been dealing with natural logs, and this is when it comes up, you shouldn't be surprised to find that natural log has a role in this. And remember, natural log happens when we have a quotient. So can you think of a way that we can rewrite tangent of x as a quotient? Okay, so I know it's been a while since we've looked at it, but tangent of x is actually sine of x over cosine of x. Okay, and so we are now expressing tangent as a quotient. And let's go ahead and see if we can pick out u and u prime. And if you remember from the previous day, we make u the bottom. Okay, and I got here without highlighters again. So we'll just start here and let u equal cosine of x. And then if we take u prime, or du, then we get negative sine of x dx. Okay, and so if we look up here, we need sine of x dx. And so what's our extra piece? What's that negative? So let's divide by it. We get negative du equals sine x dx. Okay, so now we can replace everything in here or do our change of variables. So now sine of x dx is just negative du. Okay, and I just put that negative to the outside. And then we have u on the bottom. And if you recall, that gives us negative natural log of u plus c. Okay. And then if we replace u, if I go back and do that, I guess, okay, we get negative natural log of cosine of x plus c. Okay. And so that is our integral for tangent. Okay. So I'm going to take this moment to show you the chart for all 6 of them. Like I said, I would pause the video and take a picture or write them down so you have them. Okay. Notice that the third one, nope, I guess it's the second one on the left-hand side is the one we just did. Okay. And I am afraid you're not going to be able to read that. Okay, so I'll read it to you, I guess. So you have the integral of sine u du is equal to negative cosine u plus c. Okay. Tangent of u du is equal to negative natural log of the absolute value of cosine u plus c. Okay, that's what we just did. The integral of secant u du is the natural log of the absolute value of secant u plus tangent u plus c. And remember, the absolute value is so that you ensure you're taking a log of a positive number. Okay. The integral of cosine u du is equal to sine u plus c. The integral of cotangent u du is equal to the natural log of the absolute value of sine u plus c. And then the integral of cosecant u du is equal to the natural log of the absolute value of cosecant u plus cotangent u plus c. Okay, so I don't know if this is any better. This is the same thing if you look at, I just don't know. Okay, you can email me if you can't see those, I guess. Hopefully you can go back and read those if you need to. Okay, or you can always Google them as well. So let's look at a couple more examples. Okay, so let's take the tangent of 5 theta d theta. So now that we've actually looked at the rules, I'm fine with you using the rules instead of actually deriving this. Okay, so tangent we just found out was a natural log of cosine, and instead of x we'll have to use u because we have a more complicated expression, but plus c. So in this case we're taking the tangent of something, and so we're going to let u equal that 5 theta. Okay, so remember that inside function is what we let u equal. And so du is 5 d theta. Okay. And so when we go to replace this, we can leave tangent like it is. This will be replaced by u, but we have this d theta we also have to replace. And over here we have 5 d theta. So to make it just d theta, since it's multiplied, remember it needs to be du over 5. Okay. So that d theta, it's going to be that du over 5. Okay, so we can go and rewrite this with different variables. That 1/5 I'm going to make out to the outside, and that just comes from right here. So tangent does not get replaced, but the 5 theta gets replaced by u. And then the d theta was du over 5, but we already took care of the over 5 out here. Okay. So now this matches our tangent integral formula, and it says we take 1/5 times what this would be, which is the natural log, okay, of cosine of u plus c, and I actually need a negative out there. And then if we go replace u, we end up with negative 1/5 natural log of cosine of 5 theta plus c. I think I forgot to say the absolute value of in there. Okay, but here is our answer. Okay, so we're just using that u substitution that we've used in the past, but it does end up with a natural log. Okay. So now let's look at about the integral of secant of x over 2 dx. So again, we can just use u substitution, and we want to use the inside function, which is x over 2. So if we let u equal x over 2, take the derivative, we get du equals 1/2 dx. So we know our u gets replaced up here, the dx needs replaced, but right now I have 1/2 dx. So how do I make it only dx? Well, I multiply by 2 or I divide by 1/2, whatever you want to think about it as. So we actually end up with 2 du is equal to that dx. Okay, so now we can go back and replace. Okay, so secant, and that x over 2 becomes u, and then dx is 2 du. So I'm going to put du right here, but I'm going to put my 2 on the outside. Okay. And then now we have an integration formula for secant u. So it's 2 times, and it is the natural log of secant u plus tangent u plus c. And again, I'm just using that formula for secant. Okay. Then all I have to do is go plug in for u. So secant of x over 2 plus tangent of x over 2 and plus c. Okay. And let's look at a couple more. Okay, this one I'm about to write. When I checked it on Wolfram Alpha, it wasn't like it exactly, but sometimes, remember, they are going to look different, although they are the same. So here I actually have sine of x over 1 plus cosine of x. So this is closer to what we've been doing. We have a quotient here. So let's see if we can make it work. Oops, dx. So let's go with our approach of making the bottom equal to u. So I get 1 plus cosine x. And if we take the derivative of 1 is 0. The derivative of cosine is negative sine x dx, which is pretty good news because if you look up here, we need sine x dx. And so we have sine x dx here. We just need to get rid of the negative. So we divide by the negative. Okay, so that negative du is what we're going to use. Okay, so if we go replace here, we get sine x dx is negative du. And then 1 plus cosine x was our u. Okay, and so this is what we just got done doing the past couple days. So this is natural log of the absolute value of u plus c. So in this case, we get the negative natural log of 1 plus cosine x plus c. So again, that is related to what we had been doing. And let's do one final one. And that would be we have secant of t plus tangent of t, taking the integral of that. Now this one really doesn't have an inside function because you're just taking it of t. It has an addition, so what we could do is just rewrite this. It's the integral of secant t dt plus the integral of tangent t dt is at least one way to do it. Okay, so I think what they're trying to do here is remind you that it doesn't always have to be what we've been doing, right? Don't force it to work. Okay, you could also probably factor out some things and make things happen, but let's just approach it from this way. So we do have a formula for the integral of secant of something, and that is the negative, oops, sorry, it's a positive, natural log of secant t plus tangent of t. And then we need to add the integral of tangent t, which is actually a minus the natural log of cosine t plus c. Okay. Now, is there a way to simplify it? Possibly. And actually, I would say yes, because we can make, when we have a subtraction with logs, you can actually put it as a ratio, right? Secant of t plus tangent of t all over cosine of t. So that's another way to do it. And then you probably could even divide both of these by cosine of t and maybe even get something simpler. But if you get this far, I'm perfectly happy with that because you've used your formulas. okay? And we're not pushing trig extremely hard here. So just know that there could be some other answer options. Okay, so that's all I have for you today. We will do some problems tomorrow. And please, as always, let me know if you have any questions.